In July 2025, astronomers observed something moving through the solar system, a pale fast spot that didn't match any known orbit. It wasn't orbiting the Sun, it was just passing nearby. They called it 3i Atlas. 3i means the third interstellar object, the third detected after 1i Oumuamua and 2i Borisov. No, it's not an alien spacecraft, as has been speculated and continues to be speculated. In the meantime, the gas halo around it has been measured spectroscopically, and we know for sure that it's a comet, meaning a natural object. It's just behaving unusually. For example, it's throwing water into space from a region so cold that ordinary comets would have remained completely frozen. But let's look together at all the oddities. Thank you. Enjoy watching and goodbye. 3i Atlas was discovered this year by the Atlas telescope in Chile. The orbital analysis showed a hyperbolic trajectory. That means it will never return to the Sun. It's clear evidence that it comes from outside our solar system. Shortly after the discovery, National Aeronautics and Space Administration's SWIFT telescope observed a particular ultraviolet at the wavelength of 308.5 nanometers. Why? Because that's the spectral fingerprint of the hydroxyl radical oxygen-hydrogen, a product of the decomposition of water molecules under the action of sunlight. It was a big surprise. The measurement confirmed that this comet is releasing water vapor, even though at the time of the measurement it was at a distance of over 3.5 astronomical units from the Sun beyond Mars, where ice shouldn't evaporate or sublimate almost at all under sunlight. Sublimation is the transformation of ice directly into vapor. From the intensity of the light, astronomers calculated a production rate equivalent to about 40 kilograms of water vapor per second. No need to calculate, I already did it myself. In just 1 month, the comet loses an enormous amount of water, enough to fill a sphere of water with a diameter of 50 meters. The authors of the study emphasized that hydroxyl emissions beyond 3 astronomical units are extremely rare. Most comets in the solar system only start releasing water when they are closer than 2 astronomical units, when sunlight is strong enough to melt or sublimate the surface ice. However, this interstellar comet was already active in the frozen and distant regions of space. To support such a vapor flow through ordinary sublimation, researchers estimated a minimum active surface area of about 19. But how big is the comet's nucleus? We don't know. The comet's intense brightness is dominated by gas and dust, which makes it impossible to directly observe the nucleus. However, images from the Hubble telescope allowed for an estimated maximum size of about 5 to 6 kilometers in diameter, although it could be smaller if its activity is unusually intense. This means that over 20% of the surface must be active in releasing gases, an unusually high process compared to typical comets, which only have a few percent of their surface active. But even this explanation is not enough. The SWIFT data shows that the ultraviolet brightness doesn't come from a fixed point but is diffused like a mist. The researchers have proposed another hypothesis. Large ice grains could be expelled from the nucleus and would evaporate or sublimate during flight, releasing water around the comet. In this case, the water vapor does not come only from the surface but from a cloud of floating ice particles that surrounds the nucleus. The measurements also suggest that the inventory of volatile substances in this comet is different from that of our comets. Another study based on observations from the James Webb Space Telescope brought a new surprise. Its infrared spectroscope analyzed the gases around the comet and found that they are dominated by carbon dioxide. The ratio between carbon dioxide and water is one of the highest ever observed at such a distance. About 87% of the detected gas is carbon dioxide, 9% is carbon monoxide, and only 4% is water. This carbon dioxide-rich composition could mean two things. Either the comet's nucleus is intrinsically rich in carbon dioxide formed in a very cold region of its origin system, or thermal processes are preventing the sublimation of water compared to carbon dioxide. In September 2025, another team studied how light reflects off the comet's dust. Using polarimetry, the results suggest that particles in the coma may be clumped, porous, or covered with frost, remnants from a very different formation environment. With its unusual ratios of volatile materials that evaporate easily, 3I Atlas does not fit into any known category. Some researchers think it formed in a galaxy region with few metals and strong radiation. This comet could be a chemical fossil, an imprint of the conditions from another stellar system. By tracking its trajectory through the galaxy, astronomers believe that 3I Atlas comes from the thick disk of the galaxy, the place where the oldest stars are found. That means it could be over 7 billion years old, older than the Earth and the Sun. A relic of a vanished planetary system, preserved for billions of years in the cold of interstellar space. And one important thing, detecting water on an interstellar comet shows us how universal the ingredients that can lead to the formation of planets and maybe life are. As astronomer Dennis says, when we detect water or its ultraviolet echo, hydroxyl from an interstellar comet, we're reading a letter from another planetary system. It tells us that the ingredients for the chemistry of life are not unique to us. However, we still lack a pattern for these interstellar objects. Oumuamua was dry, possibly metallic. Borisov was rich in carbon monoxide. And now Atlas is throwing out water and carbon dioxide from areas where we didn't expect this to happen. Atlas will reach Perihelion, the closest point to the Sun, on October 30, 2025. After that, it will leave the solar system forever. The Hubble, James Webb, and Swift telescopes are frequently monitoring it to observe how its activity evolves. However, in the coming months, other instruments will join as well. The Very Large Telescope Observatory in Chile will continue to perform polarimetric measurements to monitor changes in the structure of dust particles as the comet approaches the Sun. James Webb will repeat the infrared observations to determine if the ratio between carbon dioxide and water changes depending on the temperature, but also to look for traces of methane, ammonia, or complex organic molecules in the comet's coma. Also, the Solar and Heliospheric Observatory and the Solar Orbiter Probe will try to closely measure the flows of ions and dust released near the perihelion to see how fast the comet's nucleus rotates around its axis. Interstellar comets like Atlas III are time capsules from other planetary systems. Their composition shows us what kinds of molecules form around other stars. The fact that we see water and carbon dioxide coming from another corner of the galaxy shows us that maybe the recipe for life is universal. As it moves back into interstellar space, 3I Atlas has done its duty for us. It whispered to us that the basic ingredients of life, like water, are not unique to our planet. Soon the comet will disappear, never to return again. Dear friends, this was today's video. If you haven't subscribed yet, you can do it right now by pressing the subscribe button. Write in the comments what similar topics you would like and give a like and share if you enjoyed it. It helps me a lot, just like if you join me on Patreon. Until next time, I am Christian Presura, Physics Explained. You are cool. All the best. Goodbye.